It's very important for us to know about the x-intercept of the quadratic function. Suppose we have a quadratic function given as y equals x squared plus 2x minus 6. To find x-intercept, it's the value of x when y is 0. So we substitute y as 0 in this case, and x squared plus 2x minus 6 becomes the quadratic equation. And when we solve this quadratic equation, there is a formula for that. But before that, we compare this quadratic equation with the standard equation as ax squared plus bx plus c. This is 0, so the value of a for us is 1, value of b is the coefficient of x is 2, and c is minus 6. The formula for finding the roots, which are also called the zeros, which are also called the x-intercept. These three words signify the same thing. The formula for finding x is minus b plus minus under the root of b squared minus 4ac over 2a. So for this question, we already have the values of b, c and a. We are just going to substitute it here. Minus b is minus 2 plus minus under the root of b squared is 2 squared minus 4, a is 1, c is minus 6 over 2. A is 1 again. So we have minus 2 plus minus under the root of 4, minus times minus is plus, 6 times 4 is 24 over 2. So we have minus 2 plus minus root 30, 24. I made a mistake here. This is 24 plus 4, 28 over 2. So we have minus 2 plus minus 28 is 7 times 4. So we can bring 2 out over 2. So we have 2, 2, 2, it gets cancelled, so minus 1 plus minus under root of 7. We have two values here. The first value is minus 1 plus root 7. The second value is minus 1 minus root 7. These are the two zeros corresponding to the given quadratic function, which are obtained always by substituting y as 0. There are some more important things about the x-intercept of the quadratic function, which are as, for example, the value inside the root b squared minus 4ac. We call this value as discriminant. This is discriminant. Whenever the value inside the square root, whenever discriminant, that is also called as delta, if this value is greater than 0, we have two zeros corresponding to the given quadratic function. If this delta is 0, we have only one zero or one root corresponding to the given quadratic function. If this delta is less than 0, value inside the square root, if this is less than 0, we have no zeros, or because we don't have any real zeros, that is the reason we say no zeros. Of course, the imaginary zeros exist. So this is also important about the quadratic function, that discriminant is such an important factor because it helps us to know how many zeros are there which will be existing for the given quadratic function. Even if we want to show it with an example, for example, a quadratic function with two zeros will be somewhat of this kind. These are the two zeros. Similarly, the quadratic function with one zeros will be, say, of this kind. This is the point where we will find only one zero. No zeros means the quadratic function may exist in one of these forms. It's not even touching x-axis. X-intercept is a point where it crosses x-axis. If it is not crossing, we say no zero. Crosses at one point, we say 1 0. If it crosses at 2 points, we say it has two zeros. The graphs can be open up or open down. These are just an example of the cases which can be possible.